Okay, so today we are looking at simultaneous equations, and that is when we have two unknowns and we're given two pieces of information and we're trying to solve the unknowns. We can see the ones we're looking at today are just a little bit different than the conventional ones in the sense that we're actually dealing with fractions here. So here we have 1/2 x plus 2/3 y equals 6. And the second equation we have is 1/8 x plus 5/4y or 5/4 y equals 8. And so how are we going to work on this? Well, the first things first is it's very difficult to do any type of simultaneous equation when we're dealing with fractions. So immediately my first advice would be to get rid of the fraction. So if I take the first question here, or the first equation, which is this top one here, I have 1/2 x plus 2/3 y equals 6. And I would like this to have no fractions in it. That would make it the easiest for me. 1/2 x, another way of writing 1/2 x in maths is to write x over 2, or 1x over 2. Using that same method, another way to write 2/3 y is to write it as 2y all over 3 and equals 6. And you can see, so my first step is just to rewrite it in a more conventional way, which is 1x over 2 and 2y over 3 equals 6. Okay, so I'm just going to give myself a little bit more room here. And I'm dealing with 1x over 2 plus 2y over 3 equals 6. And what we have here is we've got a fraction plus another fraction. And from back in primary school, you know that you can only add fractions if you've got a common denominator. So that is what I'm going to do first of all. I'm going to get my common denominator on this side. So my common denominator between the denominators of 2 and 3 is 6. So I'm going to have 6 on the bottom equals 6. Just keep that side the same. And it will be 2 goes into 6 3 times. So it's 3 times 1x. So 3 times whatever's on top. And then the sign is plus. 3 goes into 6 twice, and it's 2 multiplied by whatever is on top, which is 2y. Okay, let's just work out the brackets then on this top line here. And now I have 3 times 1x is just 3x, plus 4y. So you can see the 2 by the 2y gives me 4y. All over 6 equals 6. Okay, so this is definitely something I can work with now. You can see here I have 3x plus 4y divided by 6. It would be very handy to get rid of this divide by 6. So if I want to do that, I can do that through balancing. And if it's a divide by 6, if I multiply it by 6, they should cancel. But what I do to one side, I must also do to the other, so I'm going to multiply this by 6 as well. And now what we have is we have the division of 6 and the multiplication of 6 cancel. And I'm now left with a normal straight line equation, which means there's no fractions in it. And my straight line now will be 3x plus 4y equals, and on the left hand side, I have, right hand side on your screens. So 6 by 6, which is going to give me 36. And this is a perfect line and perfect equation I can use for a simultaneous equation. So I've done something with the first one. I'm just going to move that over there. And now I'm going to do something with the second one here. So this one here. So I'll draw a nice big line so we know we're on to the second one. And the second one is 1/8x plus 5/4y 5/4y equals 8. And again, as I said, let's write it in a more conventional way. So 1/8 of an x is the same as writing 1x over 8, plus 5/4 of y is the same as writing 5y over 4 equals 8. So you can see on this side now here, I have adding fractions. And how I add fractions is I get my common denominator. So the common denominator between 8 and 4, I could use 16, or I can also use 8. So I'm going to use 8 myself. So 8 goes into 8 once, and it's 1 times 1x, plus 4 goes into 8 twice, and it's 2 times 5y equals 8. At this point now, I'm going to work out my top line here, which is the brackets. So 1 by 1x is going to give me just 1x, plus 2 multiplied by 5y is going to give me 10y, all over 8 equals 8. And again, on this side now, I have division by 8, and it would be very nice to get rid of it. So if I multiply this side by 8, that will cancel the division, but I also must do it to the other side. And so the division of 8 and the multiplication of 8 cancel, and I'm now left with 1x plus 10y equals 8 times 8 is 64. And that is my second equation. Okay, so now I can go ahead and do my simultaneous equations with these lines, because these lines are much easier to understand, and definitely I'll be able to get something to cancel. Okay, so what I have here now are the two equations written in a much simpler form, and I'm going to solve my simultaneous equations. My first step is to either get my x's to cancel or my y's to cancel, and I'm going to get my x's to cancel. So I have a 3x up here, so I'm going to look for a minus 3x here, which means I'm going to multiply my whole bottom line by minus 3. So draw my line. My top line remains the same, 3x plus 4y equals 36. And my bottom line is minus 3 times 1 gives me minus 3x. Minus 3 times plus 10y gives me minus 30y. And minus 3 times 64, so 3 times 64, and there's a minus, it gives me minus 192. Draw my line. My desired outcome was to get my x's to cancel. I can see that that's what happened. And so I'm left with minus 30y and plus 4y gives me minus 26y equals minus 192 plus 36 gives me minus 156. Again, I am not looking for minus 26y, I'm looking for just the y. This is all attached to it, which means it's all multiplied by. The only way I can get rid of it is if I divide this side by minus 26. But remember, what I do to one side, I must do to the other. So divide this one also by minus 26. Your minus 26 and your minus 26 cancel, and you're left with y equals. And 156 minus 156 divided by 26 is 6. So y is equal to 6. That's my first unknown. And to get my second unknown, my x value, I substitute this into either line. I'm going to choose the top line. Now, if asked, would you substitute it back into one of the fraction lines? You can, all right? It should still work out for you, but it's much easier to pick the way we've written them now. So I'm going to substitute it into the top line there, which is the 3x plus 4 equals 36. So 3x plus 4 equals 36. Sorry, 4y. I now know y is 6, so it's 3x plus 4 times 6 equals 36. 3x plus 24 equals 36. And again, I'm into balancing my equation at this point. I need my x equals a number, so this plus 24 I need to get rid of. I do that by going minus 24 on both sides, and they cancel, and I'm left with 3x equals 12, and the last answer is divided by 3, and x is equal to 4. So my answer to this equation was 4 and 6, but a lot of work needed in this because first of all I was dealing with the fractions, so I had to get rid of those. Okay, we're going to look at a second example here. Again, the simultaneous equation I feel like we've mastered at this point, but at the higher level we're going to have to do something first until we get it into looking like a nice simultaneous equation. This first equation here has got 2x plus y equals 3, and that's actually perfectly fine, very standard. But the issue I have is with this second equation here. Y is equal to 0.2x plus 0.8. Okay, so I'm going to have to try and fix this up some way to make it a lot easier for me to work with. So I'm going to write it down here. Y equals 0.2x plus 0.8. Well, I guess the first problem we have here is that normally we have our unknowns on one side and our constants or our values on the other. And so you can see we've got x and y on this side and our 3 on the other side of the equals. Whereas with the one I've been given here, my y is on the correct side and my number is on the correct side. But this value of x, 0.2x, we really need to be on the other side. So I'm going to try and get rid of that. How I get rid of that is I've got 0.2x. What I can do is I can minus 0.2x from this side. But what I do to one side, I must do to the other. So minus 0.2x on the other. And they will cancel. And I now have minus 0.2x plus y, because remember the y hasn't moved at all, equals 0.8. And neither did the 0.8. So okay, so it's looking a little bit nicer. We've got an x plus a y equals a number, but we still have to try and make this look a little bit neater. Now, remember, with equations, we can balance them by multiplying the whole equation by something, and technically it still stays the same. So I would like to get rid of the decimals here. And I'm going to multiply it by something that's going to help me get rid of all the decimals. The longer you look at this, hopefully you will get to become more aware of the little tricks and tips to help you with this. But for now, what I'm going to do is I'm going to multiply this whole line by 10. If I multiply this whole line by 10, I now have minus 2x plus 10y equals 8. I have not changed this line. This line is the same. I have just written it in a different format. And this is much easier for me to work with now. So my first equation was 2x plus y equals 3. And I've now rearranged my second equation to look like this. So I've rewritten my two equations now in a much nicer format. And I'm going to solve them by using simultaneous equations. So I have 2x plus y equals 3 and minus 2x plus 10y equals 8. That should be there. Okay, and I'm going to solve them by simultaneous equations. I'm going to draw my line. Straight away I can spot that the minus 2x and the 2x cancel, so put a line through them. And that gives me 11y, and I get that by going y plus 10y is 11y, and 8 plus 3 is 11. And obviously I want to find out what y is, so I'm going to divide both sides by 11. Those 11 cancel, and I'm told y is equal to 1. I'm going to substitute that answer in now to my top line, which was 2x plus y equals 3. It's now 2x plus 1 equals 3. We will get our numbers on one side and our letters on the other, so we're going to balance out that equation. So a minus 1 and a minus 1, they cancel. My new sentence now, or my new equation, is 2x equals 3 minus 1 is 2. I'm going to divide both sides by 2 to get them to cancel, and x is equal to 1. So my final answer here is 1 and 1. So here is the overall look at the sum. First things first was I noticed that these were not in the order I wanted. The first one was fine, so I kept that first one, but the second one wasn't. We put it first of all in the order that we wanted, so an x, a y equals a number. And then to try and make it a little bit easier, we multiplied the whole line by 10, which gave us this equation here. And we then are able to apply our simultaneous equations as normal. Okay, so my first tip is to make sure that you have the equations in the correct order. And that means I need my letters equals my numbers. So to ensure that that is the order first of all. So you may need to do some rearranging. And the second tip, when dealing with fractions or decimals, write them in a different way. So if I'm dealing with 0.2x plus 0.1y equals 4, write it in a different way by multiplying perhaps by 10. That will get rid of your decimals. Or if I'm dealing with fractions, so say 2/3 of an x plus 4/5 of a y equals 3. What you need to do here is you need to recognize that you are adding fractions, or subtracting fractions, whatever it might be. Use your common denominator, get them both under one fraction, and then see if you can do anything to get rid of the division of the fraction. So that's just a few tips when dealing with harder simultaneous equations.